Okay, so hello everyone. My name is Kaiwan, and today I'll be doing the Head Start program for the Upper Sec 4 E-Math session. Okay, so today is going to focus a little bit more on the Sec 4 mathematics side. Okay, and I have some slides to go through. Then after that, I will touch on my problem set. Then I'll go into the lecture properly. And then at the very end, there will be a Q&A session. So if, let's say, anyone has any questions with regards to the topics or anything you want to ask me, feel free to ask at the very end of the session. Okay, so I will not entertain, I'll try my best not to entertain any questions right now. Just keep all them for the very end. Okay, so let's officially begin. So let me give you an introduction of myself first. So my name is Kaiwan, like I mentioned just now. I teach both A Math and E Math. So today is the E Math session. Tomorrow will be the A Math session. Now I've been teaching for about 5 years, and this is my about 5th to 6th year teaching already. And graduating class, I think this is my 3rd to 4th year taking on a new batch of students. So I primarily teach group classes. I don't teach one-to-one because of my scheduling. Later you will see why. And also I do better in a group setting, and I tend to make things interesting. Try my best to make things interesting in a group setting. So yeah, that's why I primarily focus more on a group class rather than individual one-to-one students. Okay, so a little bit of background of who am I? So I'm currently studying in NTU right now. So I'm in my 3rd year, and I study mathematics. So that's my area of interest. And I do pure math. So I do more of the proving parts of mathematics, why math is in this way, why there are many things like topology, algebra, and whatsoever. So those are the things that I study. And I have an area of interest, and that will be under the surfaces, topological surfaces, in both the differential and algebraical side. So this one is a bit more chim, not really relevant to the O-level syllabus, but I do know my stuff, so yeah, because I study math, and I really do love math. Okay, so today's agenda. Now, what am I going to do today for the next 1.5 hours? So this session is a little bit shorter than a normal lesson because this is just a little teaser as to what things are going to be like throughout the year. So I'll give an overview of what the topics are. I think since everyone is from a graduating class, you already know what are the topics at hand, what are the topics remaining. Okay, so I'll just give a little touch on them and say a few words about them. I'll highlight some of the more difficult chapters over the years that I've encountered with students and what I can do to help you with them. Share some revision strategies and tips. Then I will complete. Sorry, it's not numbers in the 4 operations. It's set notation. My bad, typo. Okay, is set notation and language, which will be the first entry topic into Sec 4. And I'll give you a timeline towards O levels. Okay. Now, the syllabus. So I believe everyone already knows what you're studying and what you're going to be covering for the syllabus. So I believe everyone have already completed about 80 to 90% of the topics. You will be left with set notation language, matrices, vectors, and maybe a little bit of function and graph. This will be the last 3 to 4 chapters that you will be left with. And then after that, you will go on for your revision throughout the year. So just take some notes. Vectors, yes, is known to be difficult. It's a deadly chapter if you do not learn it well. And also for those that are moving on into A levels, that will be in 2 years' time. Vectors will be a topic that will come back to haunt you again. So this is the foundation stepping stone for A-level vectors and for further studies vectors. Okay. The remaining 2 topics of set language and matrices, they're pretty easy chapters, so not to worry about them. Okay, the main headache is mostly vectors. Also, vectors was last year's and 2 years ago CLT topic. So it's the common last topic that was taken out of O levels. So 2 years didn't teach lah. So right now, if COVID gets better and everything, then of course vectors will come back into the syllabus. Okay, so these are in my personal opinion, my professional personal opinion, the topics that I feel that most students will struggle with. So we'll start off with algebra. So a lot of people are just simply not good with algebra, okay, which is very sad because algebra is not difficult, but a lot of people cannot grasp like the topic and just cannot do it well because either you never practice enough or you don't know how to spot questions well enough. Congruency similarity. So I believe majority already know what this topic is. It's talking about the congruency proofs and also the formula for the geometrical similarity of solids. So a lot of people cannot write proof, and it's a same thing all over the place. In university, people cannot write proof. Same thing for here, people cannot prove things. Okay, it's the same for the properties of circle topic. A lot of people cannot see the diagram. So when all the lines start to get very funky or the diagrams get very tough, that's where people start to struggle. So these two topics will confirm come out for O's. You need to focus on them and practice a lot on them. Now for Trigo, Trigo is personally, I don't feel that it's very tough, but a lot of students say that, oh, okay, it's difficult to see the diagram again. If you realize majority of these topics are all diagram-based kind of topics. So the last 5 in particular, they are the geometry chapters. So a lot of people cannot spot, oh, you cannot see the arrowhead, or you cannot see the, hey, okay, this is the angle that I'm interested in and whatsoever. Okay, so my objective is to help you get better eyesight, of course, and to help you be able to see the diagrams better, and also to help you spot questions in a very effective way for mathematics. And the last topic, of course, like I mentioned just now, is vectors. So this is the, in my personal opinion, one of the most difficult topics in eMath, and it takes a lot of effort to actually understand this topic and to actually do it well. Now, a lot of schools focus on this chapter a lot because usually this is either you make it or you break it, lah. Okay, and trust me, it is a difficult topic. Okay, so please, when your school start going through them with you, or whoever starts going through this topic with you, please focus and spend a little bit on time on this particular topic. Okay, I know I glanced over coordinate geom, so I didn't want to put coordinate geom in this list initially, but after teaching crash course for about a year and speaking to so many students, I realized that schools didn't teach coordinate geom well, and a lot of people cannot do, when actually it's just a memorizing fest. You just need to remember what the concepts are, how to apply when a certain question appears. Okay. Now, revision. So strategy for revision, because right now it's about, I would say 10, 11 months to O's. Yeah, I think about 10 months to O's. So you hachu one more time, O level come ready. Okay, it's pretty fast. So how do you start your revision? Now, right now is actually the best time to start consolidating all of your Sec 3 knowledge before you learn your Sec 4 stuff. Okay, yes, of course, it's the holidays, Christmas is coming, but of course, it's time to start to focus a little bit on your O's and make sure you don't start too late. Okay, do not cram one day before, it doesn't work. And especially for math, it's about practice, practice, practice. So even for myself, I'm in uni now, and I've been studying mathematics for so many years. In uni, we have tutorials, and we have to do the tutorials, or else there's no way we can have practice and no way to do the questions when the questions come out for exams. It's the same for you guys. So practice is really important. There are many resources online. Textbook or questions. I provide questions. There are many resources all over the places for you to do multiple practices on the topics to get your topics very strong and ready for the exams. Okay, my suggestion is about an hour a day, but of course, it's how much you can stomach. So for me, I love math. I can do math for like the whole day. I'm fine with it. But for some, they see math, they want to puke blood. So it really depends on you and how much you can stomach. Of course, do it in a moderate level because you have other topics as well, especially triple science, double humans. You got a lot of things to study. So pace yourself well, start early. Okay, then you won't regret when you take your results next year, January. Next year, January. Okay. Now, some important tips. I think this one is self-explanatory. So you need to get your foundations right. So the whole of your Sec 3 level, you need to really gear down and get them well, because you do not have the time to go back and relearn those topics again, because there's really no time. Okay, you need to focus on your other topics and your other subjects. So take the whatever holiday you have left, or take whatever time you have left to go and refocus back onto your Sec 3. Start to bring back all the memories again for things that you need to do for your Sec 3 topics. Okay. Clarify your doubts. So anytime you have any questions, please ask as early as possible. Do not wait for the last minute. It doesn't work. You will struggle. And even though, yes, EMAth is a super easy topic, it's a super easy subject, but I think everyone, all 81 of you here know the difficulty of getting an A1 for this subject. Okay, so you need to be careful. You need to clarify everything that you do not know as soon as possible, okay, before you learn the new topics. And last thing is to be consistent. So for myself, I do a timetable. I tell myself, okay, I will do 1 hour of math, each math a day. So 1 hour A, 1 hour E. And then I'll revise my other topics. So that's for myself. It really depends on you. Please remember to focus on your other subjects as well. Don't just do the things that you're good at. Okay, so be consistent now and always practice as much as you can. Now, exams. So believe it or not, in the next 3 months, your first CA is coming. Okay, and most of the time for E, this is where the last 2 topics will be taught up to matrices. So vectors most of the time will be taught here, or they will start teaching in Feb, but will not test in mid-years. Okay, of course, it varies from school to school. You really need time to study, and all your subjects will come very fast. So please spend some time to revise, spend some time to study. Same for your mid-year, same for your prelims, and then O-level like that. Okay, this is O-levels. Okay, so in terms of revision, how I usually will do it, I will complete syllabus by Feb. So I'll even complete vectors by February. Then it's just revision, revision, revision. Okay, so I hope that's clear. Okay, so this portion now is more about the material side. So what you will receive from me if you were to come for my group tuition. Then after that, I will begin with the topics at hand. Okay, so for the first thing is that all students will get lecture notes from me. So other than the curated notes, you will get on top this set of notes that has examples and content material. Now, the set language and notation notes that you have or downloaded in the Dropbox folder, that is an example of the notes that you will get. Okay, it's like a university kind of style of lecture notes that I've adapted from. And according to feedback from students over the years, it's really effective because all the content is highlighted for you. Everything that you need to know about the topics is there. So anything that you need, all the questions and whatsoever is all there. And then the curated notes is just an additional layer on top of that to help you summarize the whole syllabus as quickly as possible for your crunch time. Now, of course, this is a graduating class. So if for the older topics, the first, I think 18 topics, I'll give you the notes pre-hand, so you don't need to worry about that. Next is homework. So problem sets is a university term, which I just coined. So I'll be using homework as a way to check how well you're doing your Sec 3 topics. And I'm a little bit different from other tutors, so I don't do it the normal tuition teacher way where they photocopy assessment book or whatsoever. No, I don't do that. So for me, my homeworks are customized for every single class. So every year, every single homework is different because I look at my class and what you're weak at, and then I will focus on your that topic. So for example, if I realize like, oh, everyone is really bad at properties of circle, then that particular week will have like 2 questions on properties of circle. And also it will vary in all the topics in upper sec. The reason is because I don't want you to forget about the content that you have studied in Sec 3. This is just like an additional booster and just more practice for you. Okay, so I took my O's in 2014. So I entered secondary school in 2010. So I have resources all the way from 2008 all the way until now, 2021. So there's many years of resources and questions waiting to be passed out to everyone. Next will be these 2 things, so class assessment and class test. So these 2 things are, it's just like how, I don't know about other tuition teachers, but some things that I do is that I want to make sure that you are ready for the exam. So I'll set exam questions and to see like, how well are you doing, and also give you feedback, give you examiner's report and what to take note of for the topics. Okay, that's about it. Wait, I think I messed up. I got 2 more slides, sorry. So solutions. So I will always provide full solutions for everyone. So that one you don't need to worry. I won't give you a question and then leave you hanging out nowhere. That's impossible. And another thing that I pride myself on doing is that I personally type all the notes, all the solutions out. They're not copied from anywhere. I hand solve it first, then I type it out. So that is something I personally do. Same thing for the O-level papers, same thing for the school papers. Okay, and all the solutions are very guided. So in case you're like at the very, very end, you need things to refer to, these solutions are actually pretty useful. Okay, but a little caveat that I do for my students is that you must do your homework. So there's a one-to-one exchange. So you give me your homework, I give you the solutions. Last thing will be all these kind of other resources that you have at your disposal with me. So there are some that I provide for Overmark for free, like monthly questions is coming back. School papers, I'll give it to my private students. Revision packages, I'll create for everyone. Quizzes, tests, I'll go through the O-level papers, provide all the answers that you need to strive for your O's. Okay, so this is primarily what I will do. Now, so let's start. Okay, so I want to give a little teaser and a little throwback to some of the topics from the Sec 3 syllabus. That's why I decided to do this problem set thing. And also, I will be doing the set language and notation chapter. So that will be, I'll be touching on the chapter a little bit at the very end. Okay, so let's officially begin. Okay, so this is my problem set. So my homeworks are all designed in the exact same way with a cover page. The next page is the formula list, and then the questions will follow after. So this particular problem set here, the head start one, is actually my next year Sec 4 first lesson. This is what's the homework. So you can see the the level that I am going at. Okay, so I asked previously for questions that people wanted me to go through, but I think no one responded, so it's fine. So I will choose instead the questions that I know that are a little bit more on the challenging side, okay, which will be question 1 and question 7. Okay, so these are the two questions that I will be covering today, and then afterwards I will do the set language and notation, the introduction to the chapter. Okay, if not, let's begin. So we'll start off with question 1. Okay, so here you go. The materials are inside the Dropbox folder. So if you want, you can go there and refer to them. Okay, if not, you can just refer to my notations. Now, I will be uploading the solutions to all 8 of the questions also, but you need to give me a while, like maybe by midnight today, the solutions will be up. And I'll be taking down the document after a week. Okay, so I will remove the link after 1 week time. Okay, but promise the solutions will go up by then. Okay, let's start. So the line y equals to k intersects the curve at A, AK, and B, BK, and cuts the y-axis at P. Okay, you need to find the values of A plus B, find an expression for k in terms of A and B, and find the equation of the line of symmetry for the curve. Okay, the difficulty for this question is question 1, parts A and part B. So it's these 2 parts here. The last part is pretty easy, so not too much there. It's part A and part B that is a little bit more on the challenging side. Okay, so the question asks you to fish out this expression of A plus B out of nowhere, out of thin air. And the only thing you're given is a quadratic equation and the coordinates of AK and BK. So obviously, we need to use them. So let's do that. Okay, so this is question 1. Oops, too big. Okay, this document that I'm writing on at the moment, so this one Sec 4 handwritten annotations, I will also be uploading. So if let's say I go too fast and you cannot catch, you can refer to it there as well. Okay, so for part A, the question is y equals to negative x squared plus 3x minus 4. Excuse me. Yeah, here. So plus 3x minus plus 4. Sorry about that. Sorry, let me rearrange my screen. Okay, great. So y equals to negative x squared plus 3x plus 4. Okay, and we know that this curve cuts both coordinates of A and capital B. So these 2 are the coordinates that are touching the curve. So what is an important property for a point that is on the curve is that when you substitute the point into the curve, the equation will make sense. Okay, so what I'm going to do is to do a simple substitution. So at A comma K, and I'm going to do the substitution. K equals to negative A squared plus 3A plus 4. Equation 1. I'm going to repeat the same process for coordinates of b. So at b comma k will be equals to negative b squared plus 3b plus 4. Okay, and great. Now we have two sets of equations containing k and a and k and b respectively. Now, what is my objective? Want to find a plus b. Okay, just take note, the WTF there is not what you are thinking. It is want to find. And another one that I use is want to show. It's not, yeah, okay, I'm not going to say that. Okay, so my objective is to get a plus b. So I need to fish out a plus b from these two sets of equations. Now, k is an burden because we do not know what is k. So if I want to get rid of k, what do I do? Okay, is to definitely equate them. So I can equate equation 1 and equation 2 together, and the k would magically vanish. Okay, so I'm going to let equation 1, equation 2, I'll get negative a squared plus 3a plus 4 equals to negative b squared plus 3b plus 4. And this is my expression. Very good. So now my objective is to get out a plus b term. That is my objective for my question. So how to do that? Let's group everything onto one side. So, okay. Now, first thing is that the 4 can cancel because they are both appearing on both sides of the equation. And let's make everything as positive as possible. So a squared minus b squared, okay, minus 3a plus 3b equals to 0. So in case you can't see it, I throw this over. Okay. Next, I can group out the terms. So a squared minus b squared minus 3a minus b. Okay, maybe I don't, yeah, correct, equals to 0. Now, I want a plus b, but clearly down here, there is no a plus b. I need to get it out. So where is it from? Ta-da, from here. Okay, this is where your identities will come in. A squared minus b squared is a plus b, a minus b. So that is where you get it out from. So a plus b, a minus b, minus 3, a minus b equals to 0. Okay, and magically, the a plus b will appear. And this is what you want. Now, instead of looking at it in like one set, like a plus b, then an a minus b, then a 3a minus b, look at it in this way. This is one set, and this is one set. And since you have two sets of expressions on the left, you can pull out common factors. So there's a common factor here, a minus b. And what you're left with is a plus b minus 3 equals to 0. Okay? And now we have a 2 bracket situation equals to 0. So therefore, a minus b equals to 0, or a plus b equals to 3. Now, obviously, you need to reject this, okay, because a cannot be equals to b. If you look at the graph, clearly they're not equal. So therefore, the final answer for part A is this. Okay? So the difficulty of this question is to be able to pull out this a plus b term. And that is something that a lot of people cannot do, because you either never see the a squared minus b squared, or I don't know what you will do, then you panic and then you cannot get the answer out. Now, there are many ways of doing this question. You can also complete the square, and then you find the midpoint and solve for a plus b. That's another way of doing it. Okay, but this is, I feel, in my personal opinion, a simpler way of getting the answer out. Okay. Okay, great. So we'll move on to part B. So for part B, sorry, wrong color. Now for part B, the question is asking, the question is asking you to find an expression of k or for k in terms of A and B. So this means that we need to re-examine the two equations. Oh, wow, I wrote so small. Oh. Okay, we need to re-examine the two equations that are given to us. Okay, so let's look at these two equations again. Equation 1 and equation 2, which is these two. The question wants k equals to something. So I cannot equate anymore because the k's will vanish. Now, what other ways do you know how to deal with equations? You can add and you can minus. If you minus equation 1 from equation 2, the left-hand side will become 1, which is not what you want. Okay, but if you add equation 1 and equation 2, you're going to get 2k on the left. So you take equation 1 plus equation 2, okay, and you can write it out. 2k equals to negative a squared plus 3a plus 4, okay, plus negative b squared plus 3a plus 4. Now, there are some things that I'm doing here that I cultivated it due to habit. So like, for example, putting brackets like this. So even though the brackets are a bit stupid and a bit not necessary, the reasons for putting the bracket there is just in case the plus sign there became minus. So if this is a minus sign, you need to remember that when you minus something from something, you need to put a overarching bracket. So this is just habits that I will cultivate for myself. Okay, so let's simplify this even further. Negative a squared minus b squared plus 3a plus 3b plus 8. And voila, I have an equation. But this is not what we want because it's clearly too complicated. So let's simplify it down. I can pull out a minus sign. A squared plus b squared plus 3a plus b plus 8. And what's the reason for doing this? Because in part A, I already know my a value. So we know that a plus b is 3. So I can use this piece of information here to simplify my equation. Though it is not super necessary, but take note that it is important to always leave your answers in as simple as a form as possible. Okay. So let's do that. Now, some people may struggle with this to figure out what is a squared plus b squared. Because some people think that a squared plus b squared is a plus b whole thing squared, and that is rubbish. Okay, so a squared plus b squared is not a plus b squared. Okay, this is rubbish. Okay, so you need to use the identities to get out the answer, or if you remember this special rule, a squared plus b squared is the same thing as a plus b whole thing squared minus 2ab. Okay, so this is a very special identity that you can use, okay, in the working, okay. So I'm going to perform this identity now. So negative, open bracket, a plus b squared minus 2ab plus 3, a plus b plus 8. Okay, and now I have all the a plus b's in the world to actually solve out. So we know that these numbers are 3, so minus 3 squared minus 2ab plus 3 times 3 plus. Okay, now remember that this is equals to 2k, so you do need to divide by 2 throughout. So if you do it correctly, you will realize that the answer is k. It is equals to ab plus 4. Okay, I received a question. Someone asked, why is it a cannot be equals to b? So if you look at your graph very carefully, so sorry, I'll move into the graph for a while. Okay, if you look at the graph, clearly a is not equals to b because these are x coordinates. So okay, one is obviously positive, one is obviously negative. This is the reason why a and b cannot be equal. So you need to reject that particular solution, or else there's no way you can get the answer out. Okay, so that's the reason why. Okay, and this is part B. Yeah, I hope I answered your question. Same thing, if anyone has any questions, right, if possible, please put it into like an open message to everyone so everyone can see. Then it's a learning experience for everyone. Okay, so we'll move on to part C. So part C is more straightforward. So question is asking you for the line of symmetry. So line of symmetry. Now, this is a quadratic curve. So to find the line of symmetry of a quadratic curve, it really depends on which equation is given to you. Sometimes you're given the standard equation, which is the ax squared plus bx plus c equation, or you are given the completed the square form. It really depends on the question. Now, there are two ways of approaching this. So I will present both of the answers. Now, the concept to use the normal standard equation is to remember that the midpoint of the two x-intercepts, okay, the intercepts here and here, the midpoint will correspond to the line of symmetry. Okay, it's the exact same thing right here. Okay, but now we have a line, so it's right here. So the midpoint of these two A and B coordinates will actually correspond to the line of symmetry. Okay, so based on this logic, we know that it is the midpoint. So midpoint is just like an average, so we can find. So let's do that. Sorry, technical difficulty. Okay, so midpoint, let's do it now. So midpoint, okay, it's just taking the average of the two, okay, which is A plus, sorry, which is A plus B over 2, which we all already know that is 3 over 2. Okay, that's the final numerical answer. But because this is an equation, so you need to remember that a horizontal line, a vertical line equation is always x equals to something. So final answer is x is equals to 3 over 2. Okay, so these are the numerical answers. So k equals to A plus B and x equals to 3 over 2. The questions can be found in the Dropbox. So if you look into the Dropbox folder under Sec 4 EMAF, under problem sets, the questions are there. Okay, I'll present another solution which ties a little bit to AMAF, unfortunately. Okay, but it's completing the square. So you can actually complete the square for this particular equation, but you need to know how. Negative x squared plus 3x plus 4. Yes, I do know that completing the square for negative coefficients is only in the AMAF syllabus, but last time it was taught in E. So that's why this question has. So I can just demonstrate it, pull out the minus sign, factorize it out. Sorry. Okay, and then the completing the square just starts as per normal, like without the minus sign there. Okay, so I'll just show it out. X minus 3 over 2, whole thing squared, plus 3 over 2, sorry, minus 3 over 2 squared, plus 4. Okay. Okay, which is the same thing. You will get negative x minus 3 over 2 squared plus 6 1 over 4. Okay, so what is the final answer? You read off from here. So therefore, x. Okay, so it's either you complete the square if you know how to do it, or you just find the midpoint. So the midpoint is a more common concept that is in all questions. So maybe that will be slightly easier than everyone. Okay. For the second line, when the negative sign is taken out, shouldn't it be negative 4 instead of plus 4? Oh yes, sorry, writing error. So it's negative 4. Thank you. Thank you so much. Yeah, but the working is still correct. Okay. Okay, let me send the link again. Hang on. Yeah. Okay. No worries. Okay. So this is question 1. Okay. Sorry, I accidentally wrote too small, but that is fine. Okay. So due to time constraint, I do need to move on. So if let's say you need this working, I will provide the typed out version of these solutions, so I can show it to you guys. Oh no, it's not on this iPad. So I will provide the typed out solutions of these questions, and also will provide these annotated ones. So the difference between the annotated and the typed out ones is that annotated I will write some content sometimes, and for the typed out one don't have. It's just solutions with like explanations when there are. Okay. Now, the next question that I want to tackle will be question 7. So these ones, the remaining questions, I feel they are pretty easy. So we'll hit 7 instead. Okay, which is this. Okay, this is from Crescent Girls in 2016. The first question was from Darling Singh School in 2009. Okay, then this is a Crescent Girls School question in 2016. Okay. If you're wondering how I know, you can just see the credit. So I'll credit all the schools that I take the questions from. Okay, so let's look at this question. Now, this question is pretty tough. Okay, so that's why I decided to look at it. So let's go with this question. Let me pull out my solutions. Okay, let's go. So the line AD is a diameter of the largest circle ABCD with center O. AC is the diameter of a smaller circle OAC. The tangent at D meets BC produced at T. BTC is pi over 3 radians. Okay, you need to show that DC is an angle bisector of ADT. Okay, that's that one. Next, you need to find in terms of pi every other angle, and then you solve the rest. Now, the difficulty in this question comes from a few parts. Number one, the whole question is in radians. Okay, so part D asks you to find the area, which is really convenient because you do need the concept in radians. But to solve angle questions in radians may be a little bit of a bit more unique to people that are not accustomed to doing radian questions. So just take a little bit of note on that. So this pi over 3, you need to know how to convert pi over 3 into degrees. So pi over 3 is just 60 degrees. Okay. So let's start the question officially. So you need to show that DC is an angle bisector of ADT. So what does this mean? Now, angle bisector is an important concept because we need to know what the definition of an angle bisector is. It's the same thing for a perpendicular bisector. What is the definition of an angle bisector? Okay, this one, if you don't know, you cannot do the question. Okay, the definition is it will cut an angle in half. It's the same thing for a perpendicular bisector. It cuts a line exactly in half. So basically in this question, what is your objective? Now, if you realize something that I always ask myself is, what is my objective? So asking yourself what is the objective is like a little signpost to yourself to tell you, okay, this is where I need to go. This is what I need to find in the question. So let's write it out. This is This is question 7.8. Okay, my objective to show that, let's look at it angles. So I want to show that ABC is equals to CDT. So I need to show that this is equals to this. So let's do it. Angles ADC equals to angle CDT. Okay, so this is where the difficulty was spiked. So how do you show? Okay, there are many ways of doing it. I will show the most simplest way to do it. So it's by adding a line. So the first thing to add would be a line connecting O and C together. So okay, sorry, the line is not straight. Draw again. There you go. Now, why did I draw? Okay, there is a reason why, because one of the lines actually tell me a very important piece of information. AC is a diameter of the small circle OAC. What does this mean? We know that this is the diameter. Diameter in circle questions have a very big implication. It means that any triangle that lies on this diameter or deals with this diameter is 90 degrees. So this is 90. Okay. Next thing, we know that AOD is a diameter. So this is also 90 degrees. Okay. So you see, without the line OC, you will not be able to see that, and then you'll get stuck. Okay, next piece of information. What do you know about triangle ODC or OCD? Okay, if you realize, this is a classic triangle in a circle, and both of them are the radiuses of the circle. So this is an isosceles triangle. If you're given that one of the angles is 90, the other two of an isosceles must be 45. Okay, so this angle right here is pi over 2. Oh, sorry, pi over 4. So we have found that angle ABC is pi over 4. Now, of course, whatever I said just now is all just speaking. So you need to translate this down onto a piece of paper. So later I will do that. Now, we know that this is pi over 4. We need to show that CDT is also pi over 4. And the question is how? Okay, good. The question actually gives me another piece of information, which is what? The tangent at D meets BC produced at T. This means that the line DT is tangential to the circle. This means that angle ADT is 90. So since you know the ADT is 90 and one of the angles is 45, obviously the last angle is 45. Shown. Okay, so this is the whole step-by-step process to getting the whole answer out. So right now, I'm going to write the proof for everyone to see. Okay, so how do you write this whole thing out? So the first thing is to show that you want to show this is your objective. ADC is equals to CDT. And you must remember, because this is an angle topic, so you need to add on reasons upon reasons upon reasons. So you need to explain every single step that you are doing. So step one, we know the angle, oops, sorry, my bad. We know the angle AOC is equals to 90. What's the reason why? AC is a diameter. Okay, and yeah, angles in a semicircle. Now, I'm abusing notation here, so I'm using this and this. Please take note that in O levels, you do need to spell out everything. You cannot just write the symbol. I'm doing it because I'm saving time. Okay, so we know the AOC is 90. Next, we know that angles COD, okay, is also going to be pi over 2. Okay, maybe I write everything in radians, so it'll be a bit easier to comprehend, a bit easier to see also. So COD we know is pi over 2 because we know that angle AOC is equals to pi over 2, and we know that line AOD is straight. Okay, so we're going to use supplementary angle. Okay, so we now know that COD is pi over 2. Next, okay, we're going to explain the isosceles triangle. So since OC equals to OD, okay, radius or circle, okay, triangle COD is isosceles. So therefore, the first angle ADC is pi over 2, sorry, pi minus pi over 2 divided by 2, which is pi over 4. Okay, angles in an isosceles triangle. Okay, so I'm abusing notation here, so just take note that all the little symbols that you see there, please write out in full in exams. Okay. Since we know the ADC is pi over 4, next, okay, we know that DT is tangent to the circle. So therefore, angles ODT is pi over 2. So let me show you. ODT is pi over 2. Okay. So since angle ODT is pi over 2, so therefore, the last angle there, CDT, which is what we want, is pi over 2 minus pi over 4, which is just nice equals to ADC, sorry. Sure. Okay, so this is the whole thing that you need to write. So everything here. There may be shorter methods, there may be a simpler method, but yeah, this is one of the ways to do it. Okay. Okay, I'll move on. Next, so we part B. Excuse me. So you need to find, in terms of pi, what is angle DCT. So I'm going to erase all the lines because some are not necessary. Don't want to confuse people. So we're looking for DCT, which is this. Now this is straightforward because we literally have everything. We know that this is pi over 2, or pi over 4, sorry, because of the question. So you can find. So let's do that. This is simple. So part B, part 1, oops, sorry. Angle, well, DCT, okay, is pi, which is 180 degrees, minus pi over 4, minus pi over 3, okay, which is 5 pi over 12. Okay, so this is angles in a triangle. Okay, simple 2 marks. Part 2. Now, part 2 is a little bit quote-unquote difficult. So let's look at it now. So the question says you need to look for AOB. So let's erase all the notations. So AOB. Okay, you stick a line. AOB. So we need to find this. So how to find? Now, a common mistake is that people use this, okay, and then go and divide by 2 because angle at center equals 2 times angle at circumference. But you must remember, in order for that to work, all the vertices must touch. So that one confirm cannot. Okay, you will fail. That's common mistake number 1. Common mistake number 2 is to look at this circle, and some people think that this angle here is equals to that. So some people think that ACB is equals to AOB, which is also wrong because the butterfly, for the butterfly to work, all the 4 vertices must touch the circumference of the circle. So this is another very common mistake. Okay. In actual fact, doing it this way is one of the closest to the answers. Why? Let me explain. So we have pi over 5 pi over 12 here, sorry. We know that this is obviously 90 because this is a diameter and we have a triangle in the diameter. So this is pi over 2. So we can find this. Okay, so let me write it out first. This is pi over 12. Now, if you have been studying your circles well and you have seen this particular shape before, you will know that for the first property, which is angle at center equals 2 times angle at circumference, there is the butterfly as well. But this particular butterfly looks a little bit different where one of the vertices actually do not touch. Okay, so if you look very carefully, there's actually a butterfly here. So here, sorry, there's the arrow here. Okay, so this is actually the arrowhead. So we are actually going to use angle at center equals 2 times angle at circumference to solve for this answer. So let's write it out. So the first thing is to solve, is to find what is BCA. Okay, which is pi minus 5 pi over 12 minus pi over 2, which is pi over 12. Okay, angles on a straight line. Okay, so the last step is to say that AOB is pi over 12 times 2, pi over 6. Okay, the reason is angle at center equals to 2, angle at. Okay, so angle at center equals to 2 times angle at circumference. Okay, so the arrow there I've already demonstrated. That is how you actually show it. Okay, so this is one of the more obscure angle at center equals 2 times angle at circumference questions. Okay, I need to speed up because I'm running out of time. So the last one will be part C. So it's given the radius of the largest circle is 5. You need to find the length of the tangent of dt. So let's erase some of the stuff. So I'm going to redraw back OC because there is something we need. We know that this is 5. Okay, so there are a lot of information here that we can use. Okay, so we know that this is 5. This is the unknown at the moment. So how to find? Okay, we have all the angles in the triangle. Okay, maybe this will help. This is a clue. Okay, so how to do? Because we know that CDO is an isosceles triangle. So these two are 5. We can find this. Okay, we can find what is CD using Pythagoras theorem. So for CD, once we have solved by using Pythagoras theorem, what do you notice? You're given a length opposite an angle. Sine rule. Okay, so first one is Pythagoras theorem, then you use sine rule. Okay, so for part C, let me do it quickly. Okay, the first thing to find is what is CD. So CD is just 5 square plus 5 square, which is the root of 50. Okay. Next, we're going to use sine rule. So by sine rule, BC over the sine of angle CTD, equals to DT over sine of DCT. Okay, you perform the substitutions on your own. Okay, you will get the final answer for the T as 7.89 cm. Okay, because you know all the angles and you know all the lengths, so I leave the substitution to you because I'm running out of time. Okay. The last one is part D. So let's erase everything again. So the question is asking you to find the area of the shaded segment. So this one is, I think, the easiest question of the whole bunch. So you're given a sector and you're missing a shaded part. So for this one is just purely conceptual. You need to remember how to do. For part D, if you're looking for the leaf, okay, this is a common shape that I call the leaf, okay, or the tip of an ice cream cone. How do you find the tip of the ice cream cone? It's the whole sector minus the triangle. So the sector is half r squared theta, and the triangle half ab sine c. Okay, if you do it correctly, just following this working, you'll get the final answer, which is 0.295 cm squared. Okay, sorry I rushed the last two parts because I'm running out of time. Okay, so these are the two numerical answers. The last two parts are pretty straightforward, so nothing much to go through. It's more of parts one, part A, and parts B, part 2. There's a little bit on the challenging side. Okay, so the remaining questions, unfortunately, I do not have the time to cover, so I will leave it first, okay, and I leave it to you to go and read through the solutions on your own. So just take note that the solutions will be uploaded. Give it either tonight, or if let's say I do not have the time, tomorrow after the AMAth sessions, okay? Okay, great. So I'll leave this up here for a while. Let me get a sip of water. Okay. So for the next 20 minutes, okay, I want to actually start the new topic, which is set language and notation. So I want to breeze through, not breeze through, but to look through my notes and to actually go through this topic a little bit with everyone. So I'm going to do the introduction to this chapter. Now there's actually another section after this. So if you notice the content page here, there's section 1, which is set language, section 2, which is set notation, and section number 3 is Venn diagrams. So I didn't put in the Venn diagrams because, I mean, this is a trial session and I don't think I'll be able to hit that session by then. Okay. Now, let's talk about set language and notation. Okay, this topic here is, in my personal opinion, really easy. Okay, because there's nothing much to this chapter, to be very honest. Okay, the most difficult, I would say, for this chapter will be the Venn diagram shading, which is section 3. But the beginning section about understanding the languages and to understand the notations itself, honestly, is not difficult. Okay, so they choose to teach this topic last because honestly, schools will finish this within 2 weeks. The Venn diagram shading may not be 2 weeks, but the initial portion may be about 2 weeks. For myself or for tutors that I know, most of them will finish this chapter within a day. So within 2 hours, they can complete the whole chapter. Okay, so let's go through this set of notes. Okay, so the syllabus outline is written below here. This is what SCAB wants you to know when you enter the exam. So you need to understand all of these notations written here. So the union, intersection, the element, not element, complement, empty, universal, subset, and not a subset. You need to know what these notations mean, how to use these notations, and how do you apply them to questions. And then you need to know what is the union and intersection of two sets. What does it look like on a Venn diagram? And also the last part, which is the Venn diagram logic here. Okay, so let's begin officially. So let's start off with the introduction. So set language and notation is actually the tip of the iceberg of this whole branch called set theory. So set theory is actually a university course that I want to take, but unfortunately my school doesn't offer. So set language, right? This whole branch of the theory and the language deals with a lot of like relation symbols, equivalence classes, and things along this line. But what we are actually looking at today will only be the language portion, which is the really tip of this huge iceberg. Okay, so let's go on to the language first. Now, set language is basically like a new form of writing mathematics. So we as mathematicians are very lazy people. Okay, I don't like to write very long lines. Like I give you an example. Okay, I'm going to give you an example right here. This means, okay, if I write this like this, so if I write this, so for example, maybe the answer is 16, and I write this E symbol, this Z symbol, and this plus symbol. What this means is 16 is a positive integer. Okay, so if you realize writing this is like 0.5 seconds, this is about 2 seconds. And mathematicians are very lazy because when we write research papers or we write theses, we need to go fast and we need to write fast. So we choose a universe of symbols and we choose to write it this way. This is what we call set language. Okay, so it's the understanding of how to use these kind of notations in understanding questions and understanding examples. Now, you don't need to worry because you won't actually see the Z symbol and its plus symbol. You will actually see a lot easier things, so don't worry about that. Now, let's start off with a set. What is a set? So a set is basically a collection of objects. So I give you an example. When I tell you I'm buying you a Lego set, what does it mean? I'm going to give you this whole box of Lego. And this box of Legos will be able to build like a car, your castle, or whatsoever. So this is a set. Okay, it's a very defined collection of an object. So I give you another example. If I tell you that I have a set of real numbers, what does it mean? It means that within these brackets are all the real numbers. Okay, every single element, like for example, in my Lego example, if I have like 3,000 parts, every single little part, we call it an element. Okay, they are an element of the set. So going back to my numbers example, if I say real numbers, okay, this means like 1, 2, 3, 4, 5, 6, 7, 8, 9. These are all elements of the set, real numbers. Okay. Now, set notations are always written in braces. So there are brackets that look like this. Now, it's not this kind of brackets. No, it's not this kind. No, cannot. It must be curly. Okay, so you must get used to drawing this kind of curly brackets. Now, when questions ask you whether I want you to define what is this set for me, you need to actually write these braces. Okay, so this is important. Now, there's a difference between the elements and the names of the sets. So we devise a notation or we devise a way to make it very clear. Capital letters defined as the set name. The small letters are the letters or the elements in the set. So I give you an example. So for example, I can say that the capital A, the set A, contains elements A, B, and C. Okay, so set A contains elements A, B, and C. So there is a difference. Okay. Now, notation. So we'll start off explaining the two most basic notations, which is this curly E and the curly E with a slash. So the curly E is the easiest to understand. It's just is an element of, or basically the word inside. Okay, so this is the symbol for E. And when you draw a gigantic slash through, it means not lah. So it's just the opposite. Okay, you can take this like equal and not equal. It's the same thing. Equal means that the left is equal to the right. The slash in the middle means you are no longer equal. Okay. So this is what it means. So for example, if the question says, this element 16 is inside B. Okay. So A must contain like 2, 4, 6 or 16, 20. Okay, and you know that this is true because the element 16 is inside set A. Clearly it is true. Okay. Now, one very important thing, some people did not know this. Okay, let me just say. Now, the order is not important. So if I say ABC, it's the same thing as saying CBA when you write it in a set. Because no matter where you arrange or you japalan everything, right? Okay, it's exactly the same. So that one important. Okay. Now, another notation that we need to take note of is this letter N in front. And this is where one of the most common mistakes will start to appear. Now, when you have the letter N in front, it means a number. Okay, so you're looking for the number in set A. When a question writes the A alone, it's the elements inside. So I want you to write it like this. But if it's an N, it means the number. So if let's say here got like 0 and 1, this means N is 2. Okay, so there is a difference. So I think there's an example here. So you need to note the difference in the answers for the following example question. So I say that I have a set A that is an integer between the ranges of 1 to 8. For part 1, I ask you to list the elements in A. And part B, I ask you to find the number of elements in A. So there's the difference. A, you need to list out every single one. So it's 1 to 8. And for the number, you need to count how many there are. Now, trust me, this is a really common mistake in many students. A lot of people were confused between these two, and it is very bad. Okay, do not throw marks like this. This is one of the examples of common mistakes that a lot of people will make. So please be really careful. Okay, let me move on. Now we go on to the notation. Okay, so I have just introduced to you 3 of the notations, which is the letter N, which defines the number, and then the E and the E slash. Okay, so these are the 3 so far. Right now, we'll talk about a new set, a new group of symbols. But before we even go there, we need to talk about how do exams or how do people define a set. There are actually different ways. There are 3 ways in total, actually. So first one is called a listing. So it's literally what I have been doing just now. I list out every single element in my set. So for example, let's look at A. A is the set containing elements 1, 2, 3, 4. Okay, if you look at B, B is the set containing elements 1, 2, 3, 4, 6, and 12. Okay, same thing for C. C is the set containing the even positive integers. So this is a set, and we call this a listing. Okay, so this is one of the most common ways that O-levels love to ask their questions. They will give you a set and they will list out whatever is inside. Okay, just take note that this ... means heading towards infinity. So you just go on all the way, and there's no ending towards the set. Okay, now let's talk about D. So D is a common mistake. So when you see a set in a set, it means a different thing. So let's look at this example here. If you notice, there are 2 sets of braces. There is one brace on the outside, and there are braces here. So what is the left meaning? The left is a set containing set A and set B. Right-hand side is only elements A and B. So there is a difference. Okay. So sometimes questions will test this to ask you whether are they equal. The answer is no. Okay. So the elements itself are very different. In the left-hand side, the element is set A. In the right-hand side, the element is A. Okay, I hope no one get confused there. Okay, they mean 2 different things. Next is a description. So description is a little bit more rare, where it's like they just say A equals to prime numbers. So this means what? The set A contain prime numbers log. Okay, this is the most obvious one where you will understand what it means. Okay, so this one, nothing too much to say. Now, this one, set builder notation. So this is the most important one, apart from the listing, because this is where questions will always ask in this style. So they will always write it in this way. So let's look at this. A is equals to X, where X obeys a property. Okay, the definition of the PX there is what property it is. So I repeat how I read this. A, okay, the set A contains X, where X fulfills a specific property. So I'll give you some examples. Let's look at the first one. A is have the elements X, where X is a natural number. This means what? Okay, inside my set of A, I have all the natural numbers in the world. Therefore, it's the set of all natural numbers. What is this X that you see there? It's just like a little notation that you use to represent what can go inside the thing. Okay, so let's talk about this for example. Okay, if you have B is equals to X, where the range of X must be between this and this. This means what? I'll give you an example. If let's say this is between 1 and 3, okay, so obviously your X is 1, 2, and 3. So what is your element, or what's your set B? 1, 2, 3. Okay, because you know that X can be these values. This little inequality down here is essentially your Px, which is the property that X needs to state out. Okay, now in exams, this is one of the most common notations out there, where they will give you an inequality. Please take note, okay, this is a tip from me, to always write out whatever this inequality states. No matter how strong your inequality is, everyone is bound to make mistakes here, because you never look at your inequality properly, or you never look at your universe correctly. So you need to be really careful when you're dealing with such a question. Okay. Now for part C is a little bit more unique, where you see like X, Y. So this one is a bit more funky, okay, a bit more rare. Okay, basically what this means is that you're looking for coordinates, where the coordinates lie on the line Y equals to mx plus C. Okay, this one I don't want to go through. So this one, if we have the time next time, then I will talk about it. But this one is really rare, so we can just ignore it. Okay, the last part of my lecture, and then we'll end off for today. Okay, which will be the symbols. So I have introduced to you the different types of notation styles, okay, which is the listing, description, and set builder. And now I'm going to teach you all the different symbols. So when you see these kind of symbols in exams, you know what they mean. Now there's a total of, I cannot remember, 1, 2, 3, 4, 5, 6, 7. There are a total of 7 symbols that we need to know. And these symbols, once you actually learn them, it's pretty straightforward. Okay, trust me. So let's start. Now, we'll start off with the universal set. So universal set looks like this. Now there are many ways of writing. You can write it like that. Oops, sorry. Like that. You can write it like that. It doesn't really matter. As long as you draw it at the top corner, and it's very obvious really. Okay. What is the definition of the universe? The universe is like your boundary. So if I say that my universe is all the numbers in the world, this means that this question is only going to deal with the numbers in the world. Can there be A, B, C, D inside? No, because my universe is like my wall. This is what I want in the question. Okay, so I have examples below that uses this universal in case it is not clear. Complement. Okay, so complement is the apostrophe symbol beside the notation itself. So what does this mean? Apostrophe means everything that is not inside the set. So let's look at the example here. This is my universe. So when I say my universe contains 1, 2, 3, 4, it means that inside this world, right, inside this question, the world, only have the numbers 1, 2, 3, 4. There is no 5, there's no 6, there's no nothing. You cannot introduce anything in, because this is the boundary of the universe. And I tell you that the set A contains 2 and 4. What this means? The complement, which is everything that is not inside A. So you ask yourself, if elements got 1, 2, 3, 4, and my set only got 2 and 4, what is not inside A? 1 and 3. So when you see this symbol in exams, it just means whatever is not inside A. That's all. Okay, that's the definition of the apostrophe, and we call it complement. Next is subset. Okay, so subset and not a subset. So it's this symbol C and the symbol with the slash. Okay, so basically what this means is this. Okay, is each element in A is also an element in B. Okay, so if you look at the example here, this one is maybe a little bit confusing, so be careful. Now I have 3 sets, A, B, and C. Okay, A is 4, 5, 6. B is 5, 4, 6. Okay, if then I say that A is a subset of B. Why? Because every single element that is appearing in A is inside B. This is why A is a subset of B. Hi, please do not write on the screen. Thank you. Thank you. Okay, so yeah, this is the definition. Okay, that the whole set of A is inside the set of B. Now, when you have the slash over there, okay, which is the A not subset of C, this means that there are elements in A that is not inside C. That is what it means. Okay, so do not confuse between this symbol of C and the one with the E. Okay, they mean two different things. So just be careful. Okay. Yep. Next, equality. So it's the equal sign. So I think everyone knows what the equal sign is. As long as A equals to B, it means that the elements are equal. So every single element in A will contain in B. Now there is a difference between this and this. Okay, just now when I mentioned the subset thing is one direction. Okay, so when I say A is a subset of B, it means that every element in A is inside B. But it does not mean that every element in B is in A. Okay, so there is a difference. Okay, so this works this way, but it fails this way. That is the difference between the equal sign and the subset symbol. The equal sign works this way and this way. The subset symbol only works in one direction. It doesn't work in the opposite direction. Okay. Now, yes, a very good question. So what is the difference between proper subset and subset? Now, in O levels, right, they only want you to specifically know what is a subset. Okay, so ignore whatever sources outside that say proper subset. Completely ignore it. Just learn what is a subset. Okay, because it will confuse you even further. Okay. Now, before I end off, I got 3 more things to say, and then I'm done. Okay. So we'll go into the empty and disjoint sets. So what this means, empty log. So let's look at an example here. I say that x must be a real number, okay, and you must fulfill this equation. X squared equals to -1. Is this possible? Okay, the answer is no, okay, because the condition here is real. Okay, it is not possible to find a value of x because you cannot square root a negative number. So basically, we will draw these symbols here. This is what we call the null set, or what we call the empty set. Okay, so if it doesn't work, it means the set is completely empty. Okay. Okay, yes, I can give an example. So to the person that asked that, can you give an example of when you should use the subset symbol and when is it equal? Okay, very good question. So let me just entertain that. Okay, I'll give you an example of a set. So I have A, let's say is 1, 2, and 3. B is 1, 2, 3, 4, 5, and C is 3, 2, 1. Okay, so I have this set. Now, it is correct to say that A is a subset of B, but we cannot say that A equals to B. Okay, this is definitely wrong. Okay, so this is, let me put here, it's wrong. Okay, if you can see, right, it is true that A is a subset of B because every single element in A appears in B. But look carefully, in your B got a 4, got a 5. Are these 4 and 5 inside A? No. So that's why this direction works, this direction fail. Okay, but if you look at A equals to C, this one confirm correct. Okay, because A equals to C, confirm correct, because 3, 2, 1, 1, 2, 3, all the same. But, and if you look the backwards, C equals to A, 3, 2, 1, 1, 2, 3, identical. So therefore C equals to A correct. Okay, so you cannot say that A is equals to B because it's not true. But A is a subset of B. Okay, really good question. Thank you for that. Okay. Okay, yeah, I need to wrap up already. Okay, so last thing is that the common mistakes here. So remember what I said just now about these notations? These notations here are sets. So you can define sets using these 2 symbols. But when you have a question that has the letter N, okay, the letter N refers to the number. Okay, when you have the letter N, it must be this way. But your NA is 0. The number in set A is kosong, while the set A is empty. So just take note, there is a difference between these 2. This is another super common mistake. Okay, please do not make this mistake in exams. Okay, 2 more things and then we are done. Okay, we'll talk about the intersection. So when we are intersecting between 2 sets, okay, what does it mean? It means I'm looking for things that are common. Okay, so this one, we can think of the word common. Oh, sorry, I just spelled common wrongly. Okay, so looking for the things that are common. Now, how do you memorize between this symbol and this symbol? Actually, very easy. You see the word intersection got the letter N, and you see the word union got the letter U. That is how you memorize. Okay, intersection means I want common. It means that if A have, B must have. Then is intersection. Okay, if it's union, what does union mean? If a union between two people, marriage, okay, it means that you not combine the two people together, but you bring the assets of two people together and you make the two. Okay, you get what I mean now. Okay, so two people hand in hand. That is what it means by union. Okay, so for example, I'll show you the difference. If A is 1, 2, 3 and B is 2, 3, 5, the intersection between A and B is 2 and 3 because these are the only common terms. 1 and 5 is not common in B and A respectively. But if we look at this, A is 1, 2, 3, B is 2, 3, 5. The union is everything. So whatever A have, whatever B have, I'm going to take. Okay, that's why this is the union. Okay, and that's all. Okay, so please do not get confused between the union and the intersection. Remember, the intersection means I want common. Union means I want everything. Okay. Now, unfortunately, I do not have enough time for the questions. Okay, so I'm just going to leave the questions here. When you have learned the topic, you can go and try. They're pretty easy questions. Okay, and I will also upload the solutions for these questions as well into the Dropbox folder. Okay, so there are a few example questions. These are what exam typical questions are going to be like. So for example, it's like this. They give you the universe, which is that. They give you A, a condition for A, and they give you B. And then they will ask you to write down what is the number of A intersect B, or what is the elements inside A union B complement. So that is where they combine all the different concepts together into one question. Okay, so I'll leave this here. Okay, I basically have finished the first 2/3 of the chapter. I'm left with just the Venn diagram portion, which I will not cover because I don't have time. So, yeah. Okay, so back to my slides. Okay, so yeah. Okay, I'm basically done. Okay, so that's all for today. But wait, before you leave, wait, before everyone starts saying thank you, wait, before everyone starts saying thank you, wait first. Okay, so this is for group tuition. Okay, so if you want to hear me continue to lecture like this, okay, you like my voice, you think my voice beautiful, okay, and you want to continue hear me talk, okay, I do have a group tuition class. Currently, there's one student inside, there's a girl there, okay, that I conducted the previous session for, and I managed to get her. Okay, so this is to open up this session again to everyone else. Now, next week, there's going to be a trial session, so it's completely free. Okay, so it's something like today, but instead of it being so joking and so jovial like today, I'll actually go into more detail about more stuff next week. So I'll cover more questions and I'll go into I'll finish up the Venn diagram portion next week as well during the trial session. So this trial session is on the 23rd of December. Okay, from 4:30 p.m. to 4:30 p.m. to 6:30 p.m. Right. Okay, it's online via Zoom. Okay, then afterwards, once the January period starts, the lessons will become physical and it will be every either Thursday or Monday, 4:30 to 6:30 p.m. Okay, so just take note also that if you sign up for both A and E, okay, and you officially become my student, you get a 10% discount. So because I teach both, so yeah, it's just a good discount for everyone to take note of. Okay, so the sign up is right here. So you can scan the QR code if you are interested in the group trial lesson next week. So it's completely free. So when you sign up in this link here, it's not to register for my group tuition, it's to register for the trial lesson. But of course, if you're, let's say, 100% really keen and you love me so much and you like my teaching, then of course, when I contact you, you can just let me know that you want to join my group class. And then we will begin the process and I will start to give you all the materials and everything. Okay. Last but not least, okay, will be the curated notes. So this is something that I just want to talk about. So curated notes is a guidebook that all the overmarked tutors are actually writing. So I've already written mine. So it contains example questions for the whole entire syllabus and use it for revision. This is a completely separate thing. Some of my private students, like in my group, purchase the notes from me as well. I will send the link into the chat if you are interested. Okay, unfortunately, the QR code is not working because that's the old form. I forgot to update. Okay, I'll just drop it here if you're interested. Okay, yeah. So that's about it. So right now, I will stop the sharing first, stop the recording. Okay.